Designing a VPN solution. A virtual private network is one of the two main ways that Windows Server 2012 natively offers both to get users into your network from remote locations, as well as, particularly with a VPN, to connect two of your locations over a public network. We'll be focusing primarily on design considerations in this nugget, including considerations for how to deploy certificates, the Connection Manager Administration Kit, concerns about firewall configuration, and sort of general firewall versus VPN infrastructure architecture stuff, as well as some concerns about bandwidth utilization, both for client-to-server VPNs as well as for site-to-site VPNs. In terms of VPN planning, there's two different types of VPNs that we'll be focusing on. The first is your standard user remote access, which means a user is VPNing into your network so that they can get to internal resources. That's called a client-to-server or just a client VPN. The other type is when you're going to be connecting two of your sites, so two offices, to each other, and rather than using a private wide area network connection, you're doing a site-to-site or server-to-server VPN. They're largely the same. They serve some of the same purposes, obviously. They use some the same underlying technologies. There's just a few different bits to them because this one, the site-to-site, is going to be up more frequently. In fact, you might configure it to just always be online, whereas the user or the client VPN is going to be very much an on-demand thing, almost like a dial-up connection. In fact, you'll see a lot of the terminology really still acts like this is a dial-up, even though we're not technically dialing a phone line anymore. So those are the two types we're going to talk about. And because we're really focused on Microsoft's VPN implementation through the routing and remote access service, there's going to be two main types of VPN, the point-to-point tunneling protocol and the layer 2 tunneling protocol. The actual nitty-gritty details between these will come in a couple more nuggets. We're really, in this one, going to focus on a lot of the design and decision-making issues. In the next nugget, we're going to talk about the design and decision-making around direct access, which is kind of an alternative to VPNs. And then in the nugget after that, we're going to look more at the implementation issues around both VPNs and direct access. So focusing on the design and decision-making, like what you're going to do and how you want this all to work for right now. The first thing I want to discuss is the Connection Manager Administration Kit, mainly because one of the biggest pains about VPNs is getting the stupid things set up on your users' computers. Now, there's a couple of easy ways to do it, I guess. One is a new technology called InternNet, and that's where you hire a bunch of college kids, don't pay them anything, and you make them run around to everyone's desktop and set up the VPN connections. If you happen to be near a college or university with a lot of college kids, then that works fine. The better way, probably, is the Connection Manager Administration Kit, CMAC. Now, where you get this, it's been in the product for quite some time, probably since Windows Server 2003, maybe even earlier. Where you go to install it changes with every single version, just to keep you on your toes. So here's where you're going to get it in Server 2012. Go to Add Roles and Features, pick your server, click through to Features, and it's actually broken out as a separate checkbox these days. You could also do this through Windows PowerShell with the Add Windows Feature command. So the RAS Connection Manager Administration Kit, CMAC, that's what everybody calls it. So we'll just run through this. Shouldn't need a restart, and it should also not take that long, but I'm just going to go grab a cup of coffee while it does this. Okay, it did finish. It did not take that long. Now, the big trick, of course, is to find it. You could push the Windows key and try and find it this way. It should show up under your Administrative Tools group, but I'll tell you, if you're already in Server Manager, this Tools will get you to just about everything. There it is. Connection Manager Administration Kit. What this does, it tells you that it creates a Connection Manager profile. What it actually does is it creates a little kind of installer. It's not an MSI, but it's the same idea. And when an end user double clicks this little installer, it will set up the VPN connection on their computer so that they can then just run down here to let's cancel this real quick. They'll be able to just run down here to their little network icon, and the VPN connection will show up here. They can just click it and say connect. So it takes away most of the complexity. So I'm going to run through this just bits of it real quick so you can kind of see what it does. The one thing that's important to understand about this is that it does very little validation. In other words, it's just kind of taking your word for everything and then creating the installer. So before you actually run through the CMAC wizard to create a connection installer, it's a good idea to sit down at a machine, manually configure the VPN, test the VPN, meaning you're going to have to hook it up outside of your network, take it home, dial up to a ISP, whatever you need to do. Really test it. And as you're configuring it, document every single option and checkbox and thing that you type so that you can then bring the working configuration into the CMAC. The biggest problem you'll ever run into with the CMAC, and I did this once, you'll click a wrong button in this stupid thing. You'll not test it like you should have. You'll deploy it to 1,000 users, and it won't work for any of them. And then you look stupid, and you have to reinstall it. So don't do that. So when you go to create this, you have got two different types. You've got to tell it if you're starting on Windows Vista, which will also include Windows 7 or Windows 8, or if you're going in for the older operating systems. You do have to create either a 32 or 64-bit version. So if you've got clients that are running a 32-bit OS and some running 64-bit OS, then you've got to create separate ones. And one of the reasons I point this out is because this statement here is just a little misleading. What it says is 32 or 64-bit processor architecture. That's not exactly correct. It doesn't really matter what kind of hardware your clients are using. It matters what operating system they're running. Because you can run, obviously, 32-bit Windows on a 64-bit processor. And in that case, it's the 32-bit that you would need. So the processor architecture doesn't actually matter so much as the operating system. So you'll walk through this. We'll create a new profile. We'll just call this work VPN connection. Give it a little file name. Do we need to add a realm name? No. And understand that this Connection Manager Administration Kit tries to be as compatible with as many different types of VPN setting as possible. If your users are dialing into a Microsoft VPN, which is what we're really talking about in this nugget, you're probably not going to have a realm name. However, you might if you're using something non-Microsoft. So understand that some of these settings are really designed for non-Microsoft VPN setting support. And I know a lot of corporations use non-Microsoft VPNs. You'll have Cisco concentrators and stuff like that. And that's where those things come into play. So we'll skip that. I don't have, this is actually a neat trick. You can take some of the phone book information from a previously created VPN connection and merge it into this one. So if you've got something you want to reuse, it makes it a little bit easier to reuse it. Okay, and here's where we add support for VPN connections. Do we want to, well, our only real option here is a phone book from this profile. So, whoops, here we go. And then, so what is the VPN server name going to be? And this has got to be something that's either an IP address, which I don't typically like to use, because if you start coding IP addresses into these things, if that IP address ever changes, you have to go redeploy all these connections, and that is a pain in the neck and confusing to your users. Once you put this out there, you really want to not ever have to take it back. So, DNS name. Obviously, .local is not one that would be publicly resolvable. You're going to want to use a DNS name that can be publicly resolvable. So it should not really be pointing to your internal DNS. It should be pointing to something that anyone on the internet could resolve. So, okay, now we've created an entry for that VPN server. We can modify this. We can create more. If you want users to be able to select different ones, they can all go into this little phone book, so to speak. So now we can also include a phone book file. I'm not going to do that, but if you do have a phone book, this is particularly useful for dial-up. It's a list of phone numbers that the user's modem could dial up to. I don't see a lot of customers use these days, but you know, in the old days, companies would buy time from vendors like Megapop who have point of access all over the world, and so you would download their phone book, and then the user would say, okay, I'm in Los Angeles, and it would use the phone book to figure out what the closest phone number for dial-up was to them. If you're using dial-up, this is important. If you're not using dial-up, then this is not important. I think most people these days are probably VPNing over the internet, not over a dial-up connection. So again, a lot of phone book action going on here. This is where you would specify the server address where updates to the phone book could be downloaded. Again, still working on oh, I don't want to enter a phone book name. And this is also not just for dial-up. You can get your VPN stuff in here too. Your VPN server addresses in the phone book too. But again, I'm not sure a lot of companies use this. It's easier just to use DNS, get the right DNS name in place, and then you can change IP addresses to whatever you want to. But, you know, whatever. Oh. Yes. Can't contain. Okay, your dial-up networking entries. This is fine. We'll use that. I don't want to change my routing tables. I do not need to go through proxy settings. Custom actions, this is pretty rare. You don't necessarily need these. You can have ones that pre-init, post-connect. Again, you tend to get these for modem dial-up connections, not so much for internet. And what graphic? You can put a little custom graphic in here. I recommend that. I'm just going to use the default because I didn't sit down with Photoshop already. This is your dialog box so that you can get very pretty here, very custom. This is the start menu icon. It's a very attractive, old school 1990s icon by default. We'll use the default help file, support information. This is important. The custom license agreement. We're not going to worry about that. Any additional files that you want dropped in here. This can be useful if there's data files that you referred to in a custom action. Like if you've said, you know, after the user connects, I want to load in this data or execute this script. That's how you can kind of bundle these things to go along with. And we'll just hit next. And boom, that file is now saved on disk where it told me. Again, no validation whatsoever. This thing is just taking the values I give it and building that installer. I can now distribute that installer however I want to. I could, I guess I could attach it to emails and send it out to people. I could stick it on a file share. Probably more commonly, you're going to use IntelliMirror, so group policy or System Center Configuration Manager or whatever other software distribution you've got to actually push that thing out, install it on people's computers automatically, and then it will show up as a connection in their networks list when they click the little network icon in the toolbar, taskbar down there. But again, no validation. Really important that you actually manually create that connection, test all those little things that you've typed in before you bring them into the CMAC. At the very least, please don't do what I did. Make sure you take the resulting CMAC package, install it on a test machine, and then test it to make sure it works with as a regular user account and everything else before you go start, pushing that out to all your end users. All right, time to talk a little architecture. There are really two distinct models for deploying your VPN server or services. I'm illustrating both of these on this one diagram. Obviously, you're going to pick one or the other. The first one you could do, which I think most companies will not choose to do, is connect your VPN server directly to the internet, meaning it's going to have an interface with a public IP address and probably a second interface with a private IP address. So the tunnel, when you VPN your users in, they're going to tunnel through the internet straight to the VPN server, and that's going to pass them off. In some cases, there might even be another firewall here. I think that would be extremely likely. So they're going to tunnel in, the VPN is going to untunnel their traffic, and then whatever needs to go through to the network gets through to the network. My experience is that that's a fairly uncommon setup these days. Most companies freak out if anything but a firewall is attached directly to the network. And I don't mean like the Windows firewall, although it's a firewall. I mean a highly scalable, manageable firewall. So this other configuration is more likely. The user is going to tunnel through your firewall to the VPN server, which will then untunnel their traffic and put it on your network. That can sometimes be done, as I've illustrated it here, with a dual network connection. All right, so this is essentially a demilitarized zone, DMZ, or perimeter network. So on this one interface of the VPN server, it's a non-public IP address, but it's different from the one that's actually on the network. It is also completely possible to do this with the VPN server only having one connection to the network. That means somebody would come in through the firewall, it would put them on the network, still tunneled, go to the VPN server, which would untunnel the traffic and put it back onto your regular network where they can access their resources. Again, I think that's probably a little less common these days. The way I've drawn it here with the two network adapters is probably considered more of a best practice just because it helps create more separation. In any event, there's always going to be some firewallage taking place here. And so it's important that you understand, based on which of the networking VPN protocols you choose, which ports have to be open. And sadly, this is just a lot of memorization. And so we're going to cover this kind of all in a hunk. We're going to go through the different protocols and what you have to do on a firewall for these different situations. So if your VPN is in front of the firewall, here are your choices. If you are using the point-to-point tunneling protocol, PPTP, you are going to need to open, and these are both ingoing and outgoing, from the internet to the VPN server and from the VPN server to the internet. TCP 1723, IP protocol 47, that's not a port, it is a protocol ID. And now those are needed regardless. If you are doing router to router, so site to site VPNs, as opposed to a client to site VPN, you also need TCP established 1723, meaning that once the connection is up, the firewall, which is going to have to be a stateful inspection firewall, has to allow an established connection to continue. If you are using the layer 2 tunneling protocol, which is IPsec, you are going to need UDP 500, that's the IKE protocol, UDP 1701, which is actual L2TP, and UDP 4500, which is the IPsec Network Address Translation, or NAT-T. You do not specifically need a filter for IP protocol 50. That is the ESP header, so that's the encapsulating security payload, but that actually gets removed by the IPsec components before the L2TP packet is passed on to the VPN server. So in the Windows world, the RRAS server. So you don't explicitly need those coming through the firewall that way. So that's when the VPN server is connected directly to the internet, and there is a firewall between it and your internal network. These are the things that are going to have to be set up. Now, it's pretty much the same set of ports, even if your VPN is behind the firewall. So we're just going to call this behind now. The difference is that the firewall will need a filter for IP protocol 50 if you're doing L2TP, because the firewall is not going to do that. Now, in a lot of organizations, it is not uncommon for the firewall to also be the VPN endpoint, and so you're not necessarily configuring a filter through the firewall. It just has to be able to listen. These ports have to be open for it. But again, for this nugget, we're really kind of assuming that you're using RRAS as your VPN endpoint, and so this is what your firewall is going to have to let through to RRAS in order for it to unwrap the tunnel and put things on the network. And that is probably the most common configuration that people use today. Now, another design concern that will freak people out sometimes is based on bandwidth. Typically speaking, you're paying for your wide area network link, and it's not infinite. It would be great if it was, but it isn't. So you want to make that as efficient as possible. And your users, if they're remote, are not necessarily on an awesome internet connection. I mean, maybe they're at home with a beautiful fiber optic line to the network, but it's also possible that they're in a hotel somewhere with really poor connectivity. So you want to optimize this as much as possible. And one thing that people can run into is that the default in a lot of client configurations is to create the tunnel to the VPN server and put all traffic through it. Now, that means if that user is trying to hit an internal resource, well, that's great. They're already there. They can hop off to whatever internal resources they need. But if they're trying to get to an internet resource, they end up coming back through the firewall to the VPN. The VPN server untunnels the traffic, puts the traffic onto the network. The network goes, oh, hey, this is for the internet. sends it right back out that same line, and then the response has to come back through. So you can see you really kind of stack things up a lot. Now, this exact situation is something that the direct access technology is designed to help avoid. This isn't something that I necessarily say you absolutely want to turn off. First of all, you can. In the Microsoft VPN client, so the piece that gets installed here, there is absolutely a setting. It is called Use Default Gateway on Remote Network. If you uncheck that, then internet traffic will go to the internet and your local area network traffic will go through the VPN. So this is also called a split gateway or split routing or split tunneling is another term you'll see. From a bandwidth utilization and efficiency standpoint, it makes sense to do that. Why route something through an encrypted tunnel only to put it right back onto the internet where it came from? However, sometimes bandwidth efficiency is not the only driving factor. Some organizations, and this is something we're going to talk about in the next nugget as well with direct access, because this really comes into play with it as well. Some organizations have invested a considerable amount of time, money, and effort into their firewall. They've built packet filters, they've built website proxies, they've built website filtering, they've put anti-malware. I mean, that thing is protecting client computers. And if your client computer happens to travel outside the network, well, then normally it's not going to be protected. But if you allow the remote default gateway to be used, then when someone tries to access the internet, even though they're being less efficient, you're still taking advantage of all that goodness that you've baked into your firewall or whatever components, collectively make up your edge devices. So there are some business reasons why you might want to not be completely efficient. You might not want people to bypass your firewall. It helps keep your client computer safe. And so that's where you kind of have to make the trade-off decision. Is it worth doubling or quadrupling up on this bandwidth in order to get that safety? Or do you feel you've deployed sufficient protective measures directly to the client that it is capable of acting as its own end device, its own edge device? It can access the internet directly through split tunneling, and you feel comfortable with it being safe. Again, it is a complete business level decision, not a technical one. The technology decision would be to conserve bandwidth because it's not infinite and it's not free. Business driver might say, well, we want the protection of our firewall even if people are deployed remotely. So just kind of, keep that in mind as you design your network here, that there's a business factor there. The trick, of course, is finding that setting because the little bugger is deeply buried. So I'm going to go to my internet connections. Actually, I should be able to just pop it up here. Right-click, look at the connection properties, go to the networking tab, open up your IPv4 protocol, click, are we deep enough yet? Click on advanced, and here it is. And you can see that this is turned on by default. So the default setting is route all of my traffic through the VPN back to the VPN server, and the stuff that's bound for the public internet gets rerouted back out. So you can turn that off, and now only the stuff destined for the remote network will go through the VPN. Internet stuff won't. And you got to make sure that that's a little bit different in the IPv6 side. So if you're going to be moving IPv6 across the network, and keep in mind, if you haven't changed anything, you are using IPv6. So you're going to have to make sure these things are configured consistently with each other. And so once that's set up, then you'll have the appropriate settings in your VPN. Now, when it comes to site-to-site VPNs, that's your VPN server creating a tunnel through a public network to another one of your location's VPN servers, bandwidth is obviously also a concern. And when we get to the nugget on actually implementing this stuff, you'll see that one thing you can do is create filters. So kind of the idea with these site-to-site VPNs is you can have them operate on a schedule, meaning they'll only spin up the connection during certain times of day. You can have them tied up continuously, but you can also have filters. And those filters both control whether or not certain types of traffic will activate the VPN, and it controls whether or not that type of traffic is allowed to pass through the VPN, even if it's already activated. So the idea is you might have certain corporate applications that you want to be able to talk through the VPN, but you might have other things maybe file services or something else, DNS, that you don't want hogging bandwidth through the VPN. So those filters are something that you can set up to kind of control that for your site-to-site VPNs as well. The last big design concern that we need to talk about is certificates. Now, this tends to come into play particularly when you're using an L2TP IPsec VPN. And I want to point out again, and this is something you're going to hear me say over and over, and I've probably said a couple of times, digital certificates are something that in our heads we tend to associate with encryption. Well, the whole point of a VPN is to encrypt things, so naturally we think of certificates. But the real purpose of a certificate is a digital ID. It is for authentication. It is for identifying someone or some computer. The encryption is almost just a good side effect of that. It's a side benefit, but the authentication is the big thing. So one of the things you can do when you create an L2TP VPN is on the VPN server, essentially set a password. This isn't actually referred to as a password. It's called a pre-shared secret. And that doesn't mean you share it before you share it. It means you share it before you use it. In other words, it's a password. It's a password that has to get set up both on the VPN server and on the client computer. And when we get to the nugget on actually setting these things up, you'll see where that gets set. But essentially, what that does is it means that when this thing goes to dial in, it provides that password, and that secret becomes the encryption key for the connection. Now, pre-shared secrets are easy to set up, and that's why people like them, because you type a word or a phrase into a text box and you click OK, and the problem is solved. The problem with a pre-shared secret is it is inherently less secure. For one, these little suckers are difficult to change. Once you've got that pre-shared secret deployed to 1,000 client computers, you are not going to be excited about going and changing it. So you've got 1,000 people, or however many clients you have, all using the same encryption key on the network, using the same password to identify themselves, and they're using it for a long period of time. That is a hacker's dream come true, because he's got a lot of traffic he can look at over a long period of time to try and crack that password. And once he does, you're not going to know he's done it. You're not changing these things, so he's going to be able to continue to ride on that cracked password for a long period of time. So pre-shared secret, easy. Pre-shared secret, not so awesome with the security. Another option is to issue certificates to your users, and you will often do this in the form of a smart card. So this is an actual physical card about the size of a credit card that gets plugged into their computer, which has to have a smart card reader. And a lot of laptops will have a port where one can be plugged in. You can plug them into a USB port, for example. They put that in, and your smart card has a copy of their certificate, and somewhere in your network, often on an Active Directory domain controller, there will be another copy of that certificate. And that provides each side with a shared secret. So usually it'll be the private key on this side, and it'll be the public key on this side, and that is what is identifying the user to the network and providing the encryption key for the VPN itself. Now, actually deploying smart cards is way beyond the scope of this particular nugget, but if you've gone through the trouble of deploying smart cards, they're a great solution for VPN authentication and encryption. A lot of organizations don't want to do that, though. And it is not a hassle-free process to deploy smart cards. And, people lose them and they sit on them in their wallet and they crack them and they have to get them replaced. It is not without its problems. So another option is to go with a computer certificate. Rather than deploying it to the person, you deploy the certificate to the computer that they use. And again, it has a copy, and somewhere on your network, usually Active Directory, there's another copy, and that allows the computer to authenticate to the network, and the user then authenticates through that connection. So you're still authenticating the user, usually with a username or password, if that's the case, but the computer is able to spin up that VPN first and identify itself to the network. Now, the neat thing about computer certificates is if you are using a certification authority, or CA, that is compatible with Active Directory, and Microsoft's Active Directory certificate services obviously is compatible, then you can set up auto-enrollment. Now, again, setting up auto-enrollment of certificates also outside the scope of this nugget, but you can do it. And it means that every computer on your network can automatically receive a certificate. So this becomes very easy to deploy. So easy, in fact, that you're more likely to have problems with the computers where you have to manually deploy a certificate. So I at least want to show you where you would go to do that part of it, because that's definitely a little bit harder. Now, if you've ever requested an SSL certificate for an IIS web server, the process here is very similar, but you don't need IIS for this. So I'm going to start by hitting Start Run. Well, if I had a Start menu, I just hit Windows R to get the run. And we're going to open a blank MMC. Let's add a snap-in, the certificates snap-in. I want to focus it on the computer account here, and this is important because we want to assign this certificate to the computer. We'll do the local computer. Get this expanded so it can read through everything. And then in the computer's personal certificates, we're going to request a new certificate. So you've got a couple of ways that you can go through enrollment. There's an Active Directory enrollment policy. You can add a new enrollment policy, whatever you've got set up in your organization. If you pick one that has not been set up, it will do this to you. Oh, I can't set it up. That's fine. We can go in and set up a new certificate request. You enter the enrollment policy server. So this is your certification authority, how you're going to authenticate to this thing anonymously, username and a password. Windows Integrated means use your logon credentials, do whatever you want there. So this is how you create this individual policy to set up. Once that's done, it pushes off the request to that server. That server will issue the certificate in accordance with whatever business policies that your organization has set up. And then the certificate will be returned to this computer where you would install it into the personal store. And I probably don't know. I don't have any in there now, but that's okay. We do have some trusted root certification though. So these are the ones that I'm set up to deal with by default. Again, this does require that you have public key infrastructure. It requires you to have certification authorities installed on your network. If you have one and you're in a domain environment, it makes every bit of sense in the world to just set up your CA to do Active Directory automatic enrollment. Again, that's something that you learn about in the MCSA focused exams, but once you set that up, all your computers automatically get that certificate information. So this is the big design decision for you at the VPN stage of this, though. The design stage is, are you going to use certificates? If so, what kind, user or computer? And if so, how are you going to get them out there? Are you going to give it to users on a smart card? Are you going to do manual deployment of computer certificates? Are you going to do automatic enrollment of computer certificates? Does your environment have a setup that allows automatic enrollment? Do you maybe have some non-domain member computers? Because those won't be able to participate in automatic enrollment. You'll have to plan to do this manual enrollment with those. And that's really where you're at right now. What does the environment look like? What is going to work? What's going to meet the business need? So those are some of the major design considerations around a VPN, particularly when using Microsoft's RAS VPN solution. You'll have to think about how you want to deploy certificates if you plan to use certificate-based authentication, and whether or not you want to, given that it does involve some extra infrastructure. Whether or not you want to use the Connection Manager administration kit and what you can and cannot do with that thing. Firewall configuration, definitely a big deal as you're designing the infrastructure, and bandwidth concerns. Now, those are something that you don't necessarily have to decide up front, but man, it can sure be helpful, particularly that client to server piece, because it's not easy to go change that little checkbox for all your users once you've deployed that connection. I hope this has been informative for you, and I'd like to thank you for viewing.